Hey guys, Mrs. Young here. Time to go over our Chapter 3 Wave Study Guide in preparation for our test coming up. So there are two different categories of waves. We have our mechanical waves and we have our electromagnetic waves, which we are going to abbreviate EM. So the types of mechanical waves are sound waves, water waves, seismic waves. So the seismic waves are our earthquakes. Our sound wave is our only longitudinal wave that we have. Our water wave is going to be a combination wave. It's also called a surface wave. So the type of medium that these mechanical waves can travel through, remember media is going to be the plural for medium, is a solid, liquid, and gas. The mechanical waves are going to travel fastest through a solid because if we transfer the energy from particle to particle, it makes sense that the solid is going to be able to go through the solid quickest because the particles are packed super tight together. They cannot even move. They are able to maintain their own shape and volume. So it's going to move fastest through a solid and slowest through a gas because the particles are farther apart. The parts of the wave, we have a crest and a trough, and a crest and a trough, and a crest and a trough. We have a compression wave and a rarefaction for our longitudinal. This one, guys, you are going to remember what it looks like because you are going to think about what your slinky looked like. So you're going to have your compressions area where they're closest together and your rarefactions where they're farther apart, and compressions where they're closer together, and rarefaction where they're farther apart. Okay, so our electromagnetic waves. There are 7 of them. We are going to study them in more detail in Chapter 4, but we have radio, microwaves, infrared, visible light, which is what we see. It's the only EM wave that we can see. We have ultraviolet, X-ray, and gamma. Microwaves are responsible for heating up our popcorn and our hot chocolate. We use those in our actual microwave ovens. We studied that a little bit in Chapter 2 with our energy transformations, and also responsible for our cell phone coverage. So the types of mediums that they can go through solid, liquid, gas. But the big one here is our empty space. If we think that electromagnetic waves, they are radiant energy. So they are going to come from the sun and travel to Earth through this empty space, this vacuum. Mechanical waves are unable to do that. So the part of a EM wave, since it's a transverse wave, we're going to have crest, trough, crest, trough. Okay? So light waves change direction due to refraction. So think about when we had that little glass of water and we put our pencil in there and we put in the marker, whatever else we put in that water, and how it looked kind of funny from underneath because the light waves happens because the refraction occurs when a light wave changes speed. So the speed of light coming in, it's going to slow down as it hits this new medium, this new water medium, and it's going to slow down as they move from the air into the water. It's because it travels the fastest. EM waves travel fastest actually from out in outer space, but then second in air, and then slowest in our solid. So the light wave is coming in. As soon as it hits that medium, that water medium, it slows down because the water is less dense than the air. So light travels fastest in air and slowest in the water. Actually, way fastest in outer space. In that vacuum. Okay. So here, what you are going to need to be responsible for your test is being able to look at a picture and being able to tell what part of the wave is being shown. Okay, so the big ones are going to be your crests and your trough, the high part and the low part on your wave. you're going to want to know that this is the rest and that the amplitude is rest to crest or rest to trough. Okay, the amplitude is that. That's the measurement of how much energy that wave is carrying. Your wavelength is going to be crest to crest or trough to trough. With your longitudinal wave, you're going to look at your areas that are close together. That's going to be your compressions. And areas that are farther apart, that is going to be your rarefactions. With this, the direction that the energy move is parallel to the disturbance. With a transverse wave, it's going to be perpendicular, like a right angle. But we can also think about that as an upside down T. So T and transverse goes together. And parallel, look at all those L's in parallel, and longitudinal starts with L. So put those two together to help you remember. All right, so this picture here, we did this in class that one day where we were drawing our high frequency, low amplitude, or high frequency, high amplitude. Big thing here, you're going to, once again, need to know and be able to label the parts of the transverse wave. We know that this is low amplitude versus high amplitude because it's resting here in between. Now, if we were looking for a high amplitude wave, well, let's make that a little bit darker. Or high amplitude is going to go all the way up, all the way down, all the way up, all the way down, all the way up. Okay, so another thing I want you to remember is that if you are given the distance between the crest and the trough and are asked to find the amplitude, if you know this entire distance and you're just asked for the amplitude, you're going to take what you're given and divide it by 2. So, for example, if you are told that the distance from crest to trough is 10 centimeters, and then you're asked what is the amplitude. Well, I know that the amplitude is from rest to crest or rest to trough. So if I know the entire crest to trough and I'm just asked to find the amplitude, I'm going to divide that by 2. So the amplitude of this wave would be 5 centimeters. If I'm asked, if I'm told that my rest to crest is 20 centimeters, then my amplitude is going to be 10 centimeters because it's just half of what the total distance is. All right, so now here's the section where we needed to do some calculations. So once again, we have a triangle. What do all of these things mean? We have S at the top here. That's going to be our speed. Speed's always at the top. Remember, speed and velocity, those could be interchangeable on your story problems. We have F here for frequency and W for wavelength. But also remember, we've got that lambda symbol. All right, so what are we going to try to find here? Let's look at this very first question. We're going to find the formula for finding the speed of the wave. Okay, so whatever I'm trying to find is what I'm covering up. What am I left with? Frequency times wavelength. When they're right next to each other, we're multiplying. So what are we trying to find out next? We're going to find frequency. So I am going to cover up my F. So what am I left with? Speed divided by wavelength. Speed divided by wavelength. And the unit for that is going to be hertz frequency. Up here, unit for speed is meters per second. All right, so my third example was I am looking for the wavelength. All right, so I'm going to cover up wavelength. What am I left with? Speed divided by frequency. Speed divided by frequency. And it's a length, and my unit is going to be meters. All right, so let's put that to the test here. Let's change our color to red. All right. The story problem says, a sound wave has a frequency of 815 hertz and a wavelength of 3.1 meters. What is the speed? All right. So what am I looking for? I'm looking for the speed. So I'm covering up the S. I'm going to look at my formula. It's frequency times wavelength. I'm going to look for my frequency. I know that's my frequency because it has a hertz. So it's 815 times wavelength. I know that this is my wavelength because it has a length measurement. So 815 times 3.1, and we are definitely using our calculator, and that comes up with 2,526.5 meters per second. It's speed, and our speed always has two parts, distance divided by time. So meters per second. All right, my next story problem is this. A sound wave is traveling at 859 meters per second, that's speed, and has a frequency of 27 hertz. What is the wavelength? All right, so what do I need to figure out? I need to figure out wavelength, so I'm going to cover that up. What am I left with my formula is speed divided by frequency. Now, it is super important that you pay attention to which number goes up on top. It's speed, so I've got to put 459 meters per second because meters per second is my speed. That goes on the top of my fraction. And the frequency of 27 hertz, I know that's hertz because I know that hertz is a frequency measurement. That goes on my denominator. This here, guys, is divide by. So I'm going into my calculator, 459 divide by 27. That comes up with 17 meters. That makes sense because I'm trying to find length. So you are going to have a few of these calculations to do. You're going to be able to have scratch paper. You're going to be able to write down your triangle on here. You're going to be able to use a calculator. Okay, so slow down when you get to these on your tests. Okay, so I'm going to end the first video here, and we'll pick up with the second one. See you soon.